Let me tell you about the morning I walked out to my pond and found $40 of fish floating belly up at the surface. Bluegill mostly. A few small catfish from a hatchery 2 towns over. I had stocked them 3 weeks earlier. I had tested the water. I had followed the book. And they were dead by Tuesday. I stood there holding a pool net like it was going to help. Here's the part that stings. I taught 9th grade biology for most of my working life. Food chains, nitrogen cycles, trophic levels. Then I built a pond in my own backyard and killed everything in it inside a month. So today we are going to walk through what I missed. A backyard pond is not an aquarium. It is an ecosystem with 4 layers, and if you skip one, everything above it collapses. Here is what actually works. Here is a number that stopped me cold the first time I read it. Auburn University has run pond productivity research since the 1960s, and one of the long-running findings was that a small polyculture pond, think under 100 square feet of surface area, can produce a few hundred pounds of fish per year in the upper range of well-managed trials. You can pull their extension papers and look at the stocking rates yourself. Compare that to a pasture the same size running cattle. A pasture that's small produces effectively nothing. A beef cow needs acres, not square feet. And even then, you are looking at a fraction of that protein density per unit of land. The pond wins on density by an order of magnitude. Now ask why. This is photosynthesis doing your homework for you. Sunlight hits water. Algae grow. Zooplankton eat algae. Small invertebrates eat zooplankton. Small fish eat invertebrates. Bigger fish eat small fish. Every step is a free conversion. You did not buy feed. You did not haul hay. You did not run a tractor. The sun did the work and the water stored it. In a pasture, you are skipping straight from grass to cow, which is only 2 trophic steps, and the cow is enormous and needy. In a pond, you have 3, 4, 5 conversion steps between sunlight and your dinner plate, and nature handles every one of them while you are at work. Compare the labor side. A cow needs pasture rotation, fencing, water hauling, vet visits, worming, hoof care, calving attention, maybe winter hay. A pond needs, and I mean this literally, a de-icer in winter, an occasional skim of excess duckweed, and a weekly walk around the edge. The first year I kept a notebook of the hours I spent on the pond. The total came in around 12 hours for the whole year, and most of those hours were the first 2 weeks of setup. 12 hours a year for a protein system that produces food every month the water is liquid. Here is the anti. This does not mean you will match the upper-end research numbers. Those trials were optimal polyculture conditions with careful stocking, supplemental feeding in some cases, and scientific monitoring. A backyard pond at home, run with reasonable attention and no purchased feed at all, lands more realistically at 50 to 100 pounds of harvestable fish per year once the system matures. That is still more pounds of clean protein than most suburban lots will ever produce from any other source. Year 3 onward, the trajectory is flat, predictable, and effectively free. One more thing before we move on to the layers. A pond does not care about your soil. I had heavy clay on one side of my property and sand over gravel on the other. Neither grew a vegetable worth bragging about. The pond does not need topsoil. It needs a hole, water, and sunlight. If your yard has been defeating your garden for years, if you have tried raised beds, amendments, compost, the whole routine, and the garden still underperforms, this is the system that stops caring about your dirt. It is, in the most literal sense, above all that. 4 layers. Every working pond has them in this order. Skip one and the system starves the one above it. I am going to walk through all 4 because the order is the whole game. Layer 1, ducks. Ducks are not optional. They are the nitrogen input that starts the chain. I run 3 khaki Campbells. That is the breed for backyard work. They lay between 280 and 340 eggs a year. They forage hard for slugs and snails and bugs, and they do not fly off the way mallards or wild stock will. You can clip one wing if you are nervous. Most Campbells do not try. Their manure drops into the water and feeds the next layer without you lifting anything.
The water currents then carry these
One duck
nutrients,
produces
flowing
roughly a
directly.
pound of nitrogen-rich waste per week in the wet season. 3 ducks, you have your fertilizer problem solved for free, and you still get a daily egg from each one through most of the year. A word on housing them. Ducks need a dry shelter at night, a small coop you can lock against raccoons, and a ramp into and out of the water. Raccoons are the #1 predator for backyard ducks in every region I have checked with the Extension Office. A 4 by 6 foot coop raised 6 inches off the ground, with a hardware cloth floor vent and a latch a raccoon cannot rotate open. Costs under $100 in lumber if you build it yourself. Do not skip this. I lost a duck in year 2 to a raccoon that learned to open a simple barrel latch. Replaced it with a 2-step carabiner clip and have not lost one since. Layer 2, aquatic plants. 3 functions, 3 plant types, and I want you to remember these names because they are cheap, local, and they do everything the expensive pond supply websites charge triple for. Cattails on the shallow edge. They are the primary biofilter. Their roots pull nitrogen and phosphorus from the water column before algae get too aggressive and turn your pond into pea soup. Hornwort fully submerged. It is an oxygenator, a spawning structure for fish, and it outcompetes filamentous string algae if you get enough established in the first month. Duckweed floating on the surface. It shades the water, reduces evaporation, and runs around 25 to 30% protein on a dry weight basis. You may have seen blogs claim 35 to 45%, higher than soy. That is overstated and has been for years. Real analyses put it in the range I just gave you. Still impressive, still free, still doubling every 48 hours in warm weather while you sleep. Small aside, medieval monastery gardens in Central Europe kept carp ponds right next to the kitchen garden. And the monks worked the same 4-layer logic 800 years before Auburn researchers wrote it down in academic English. They did not have the biology vocabulary. They had the results. Layer 3, fish. This is where most backyard ponds get it wrong, because people stock one species and call it done. Bluegill is your anchor. They self-sustain. They spawn 2 or 3 times in a good season. And a 1-acre pond can support over 1,000 of them if the forage base holds. Scale that down for backyard math. Roughly 50 fingerlings per 1,000 gallons is a safe starting stock. A 10 by 15 pond, 4 feet deep, holds somewhere around 3,000 gallons, so 150 bluegill fingerlings at $1 apiece from a regional hatchery is the right opening move. Channel catfish next. They clean up the scraps and grow to dinner size in 2 years, hardy and cold. 10 catfish is plenty for the whole pond. Tilapia, if you want a fast-growing warm water fish with white flaky flesh. But read this carefully. Tilapia is illegal to stock in outdoor water without a permit in several states, including Florida, Arizona, and parts of Texas, because they can escape and invade warm water habitats. Check your state fish and game rules before you buy. Do not skip this step, and do not let a feed store clerk tell you otherwise. A $20 fine becomes a $400 fine in a hurry. Layer 4, bacteria. Invisible, critical, and the one the books underexplain. Nitrifying bacteria, 2 main genera, Nitrosomonas and Nitrobacter, if you want the names, convert fish waste and duck manure, which arrives as ammonia, into nitrite and then into nitrate. Nitrate is what plants use. Nitrate is fine. Ammonia at any measurable level kills fish. No bacteria colony, ammonia accumulates, fish suffocate. This is what killed my first batch. I had clean-looking water. I tested for nitrate, and the number looked okay. I had not tested for ammonia, and I had not given the system time to build a bacterial population. So the ammonia spiked overnight on the second warm week, and the fish were gone by morning. You do not add bacteria from a bottle. You wait for them, 6 to 8 weeks after you fill the pond, before any fish go in. Plants first, ducks second, fish last, in that order. The bacteria show up on their own once the food and surface area are there. If you want to verify instead of trust, get a freshwater ammonia test kit, about $15 for the liquid drop type, which is more accurate than strip tests. Your ammonia reading before stocking fish needs to be at 0 parts per million, not close to 0. If you see any yellow-green tint in the vial against the color chart, the system is not ready. Wait 2 more weeks and test again. Every person I know who has failed at a backyard pond failed at this exact step, and every one of us learned it the same expensive way. The elegance of this system is that each layer feeds the one above it without any input from you. Sun feeds algae and plants. Plants feed zooplankton and provide oxygen. Duck manure feeds bacteria. Bacteria convert waste into plant food. Fish eat zooplankton and small insects. Ducks eat duckweed and insect larvae. You eat the fish and the eggs. The loop closes without a feed bag, without a purchased amendment, without a weekly trip to the farm store. I buy 3 things for this pond in an average year: a replacement de-icer element every 4 or 5 winters, a small bag of oyster shell grit for the ducks, and occasionally a new net when a raccoon chews the old one. That is the whole input budget. Now the practical part. If you decide to build one, here is the actual sequence. Site selection first. Find the lowest point on your property that gets at least 6 hours of direct sun per day. Low point because water collects there naturally, so your pond sits with the grade of the land instead of fighting it. Fighting grade means leaks, erosion, and liner that slides. 6 hours of sun because algae need photosynthesis, and without algae the food chain never starts. Shade on one edge is fine, even welcome, for summer temperature regulation. Full-day shade kills the system before it begins. Size: 10 feet by 15 feet, 4 to 5 feet deep at the center. That gives you roughly 3,000 to 4,000 gallons depending on the slope of the sides. Add a shallow shelf 1 foot deep and 2 to 3 feet wide around at least one side. This is where cattails go, where ducklings learn to paddle, and where frogs and amphibians stage for spring. The deep middle is for fish to winter over without freezing to the bottom. Do not skip the depth. 3 feet is not enough in climates that freeze hard. Go for minimum. Liner versus clay. Heavy native clay soil? You can puddle it, meaning compact the clay by working it wet until it holds water on its own, and skip the liner. Old farm ponds in the Midwest run this way and have for generations. Sandy or mixed soil. You need an EPDM liner, 45 mm thickness, fish safe rated. A 10 by 15 pond takes about a 20 by 25 foot sheet of liner once you account for the drop to the center and the edge wrap that anchors under a border of rock or sod. Budget $200 to $250 for the liner alone, full cost. $400 to $600 for the whole build if you dig it yourself. Breakdown: liner $250, de-icer $40. 3 started ducks around $150 total. 50 to 150 bluegill fingerlings at $1 apiece. 10 channel catfish at roughly $3 each. Plants you can mostly collect locally or split from a neighbor's existing pond, for free if you know someone. The dig is a cost in labor, not cash. A full weekend with a friend and 2 good shovels, or 4 hours with a rented mini excavator at around $350 a day. Staged stocking. This is the part competitor videos rush through, and it is the reason so many first ponds fail. Fill the pond. Let it sit 1 full week. Add plants, cattails on the shelf, hornwort into the deep section, a small handful of duckweed on the surface. Wait 2 to 4 weeks for the plants to root and start doing their work. Add the ducks. Wait 4 more weeks while the bacterial cycle builds, and you see the water begin to shift in color. Green algae bloom, then brown haze as the zooplankton arrive and eat the algae, then slow clearing. Test the water if you have a kit, or just trust the timeline. Then and only then add fish, and add them in 2 waves a month apart, not all at once. My dead fish were dead because I dumped 100 fingerlings into a 3-week-old pond with no bacterial colony. Everything I am telling you about layer order and timing, I learned from that $40 Tuesday and the sad phone call to my wife that afternoon. One more anti. Do not stock tilapia if your winters drop below 55 degrees Fahrenheit without a clear plan to harvest every last one of them before the first hard frost. They do not overwinter in most of the United States. They will die in a heap at the bottom of the pond, and you will know by the smell in late October. Bluegill and catfish tolerate cold. Tilapia is a summer tenant, not a resident. Timeline. Because this matters and nobody explains it properly. Year 1. The pond looks rough. The water goes green for a while, then brown, then cloudy, then starts to clear around month 3. That is normal. It is the bacterial population stabilizing and the algae plankton balance finding itself. Do not panic. Do not add chemicals. Do not dose it with anything from a bottle. The system is wiring itself up. Year 1 is the patience year. You are not supposed to be harvesting anything yet. You are watching. End of year 1. I can tell you exactly where I was standing. October, late afternoon, the light low over the shallow edge of the pond. I walked out with a cup of coffee because the dog wanted a walk. I saw a flash of silver near the cattails. Stopped. Stood there holding the cup like an idiot. Another flash. Then a third. The first bluegill I had actually seen since I stocked them in June. They had been there the whole time, growing in the deep water where I could not see them, and I had spent months assuming the pond had failed again. It had been working the whole time while I was not watching. Year 2, you harvest the first catfish. Small ones, not trophies. 8 to 10 inches, maybe a pound on the scale. Enough for a dinner for 2. The bluegill are reproducing on their own now. You see fry on the shallow shelf in June and July. Tiny darts of silver that were not there last summer. The duckweed covers maybe a quarter of the surface, which is what you want. Enough to shade and feed the ducks. Not so much that it chokes oxygen exchange at the top of the water. Year 3, the pond is self-sustaining. You are harvesting fish a few times a month through the warm season. The ducks are laying. The shallows are full of frogs, and the occasional heron visit. Build a net cover over the shelf if herons find you, because they will, and they are efficient. You are not adding anything. You are not buying anything. You walk around the edge once a week and you watch. Winter. Here's the detail most videos leave out. A de-icer, a floating unit you can get for under $50, goes in the deepest section of the pond. Is not there to keep the water warm. It is there to keep one small hole in the ice open. Why that matters? Decomposing plant matter at the bottom releases gases through the winter, and under a sealed sheet of ice, those gases have nowhere to go. Fish die under sealed ice, not from the cold, but from anoxia and gas poisoning. The de-icer prevents that one thing. Bluegill and catfish winter fine in water that stays above 34 degrees at the deep end. If you stock tilapia, you should have harvested them in late September, as I already said. The fall harvest is the other winter task nobody schedules for you. Late September or early October, before the water drops below 55 degrees, walk the edge with a cast net or a rod. Pull out anything tilapia if you have them. Pull out catfish you want for the freezer. Thin the bluegill if they are crowding. A pond with too many bluegill ends up with stunted fish that never reach harvest size. Rule of thumb, if you are catching bluegill under 4 inches long in year 3, you are overcrowded. Take 50 or 100 out. Clean them at the edge of the pond. Their guts go back into the water. Nothing wasted. Here's what the classroom years taught me that the books did not. Most students do not fail because they cannot learn the material. They fail because nobody assigned them the one problem that would have made everything click. The one task that turns the idea into something their hands understand. Here is your test this week. No list of 3 steps. No checklist. One assignment. Walk your yard after the next rain. Do not garden. Do not rake. Do not mow. Walk. Find the spot where water collects. The dip at the low corner. The place where the grass stays green into August, when everywhere else has gone brown. The swale nobody planned, but the rain figured out anyway. Take a tape measure. Measure the length. Measure the width. Write the numbers on the back of a grocery receipt or on your phone. That is it. That is your pond site. Not because some book told you. Not because a YouTube video drew a diagram. Because water already chose it. And water is the only thing in this whole system that gets to vote. If the space is at least 10 feet by 15 feet and it catches 6 hours of sun through the middle of the day, you have the start of a $400 protein system that will outlive your mortgage. If it is smaller, you can still build, scale the numbers down proportionally, drop to 2 ducks and 100 bluegill, and keep the same structure. If the spot is fully shaded, look at the second lowest point instead, or at the edge where the shade breaks. If you have no low point at all, you have an unusually well-drained yard, and you can dig anywhere that will not flood your foundation when the pond overflows in a storm. Here is the part I did not understand for years, and this is the thing I wish someone had handed me in my first season. The pond does not need to be ambitious. Mine is not. 10 by 15 feet. 3 khaki Campbells. A bluegill population I have never actually counted because I cannot see the bottom. Some catfish that come up to the edge when they hear the door slide open. A bank of cattails on the north edge. A thin skin of duckweed that drifts into the corner when the wind picks up. A de-icer that costs less than dinner for 2 at a diner. It feeds us. It runs without me. It asks almost nothing back. Do not buy anything yet. Do not order a liner. Do not call a hatchery. Do not dig. Just walk the yard after the next rain and measure the low spot. That's the data.